Hi there. I wanted to do a video about logarithmic equations, and some people think about these in different ways. I like to think about them in terms of what a logarithm is by definition. So I wrote the statement down here. Whenever you have a logarithm of any base, and remember b can be any positive number other than 1, and you have this logarithmic statement, it means, well, here, I'm going to use a different color. This means the following. B raised to the power of y equals the number you substituted into the logarithm. These are always the same. It's how logarithms are defined, and it's why they're so useful. So to solve log base 4 of all this mess equals 15, I'm going to identify the base b. The logarithm is base 4. The number that I have substituted into the logarithm is not a number, but rather an expression. It's a binomial, two terms, squared. And the number that we get from finding log base 4 of this expression is 15. So which number do you find log base 4 of after raising 3x plus 4 to the 5th power? Find log base 4 of that number, gives you 15. So we begin by rewriting this as an exponential statement. So we have 4 to the power of 15 equals 3x, and I don't know why I wrote 2 here. This should be 5. I don't know what I'm thinking. So this should be to the 5th power. 3x plus 5 to the power of 5. So now I'm going to switch over to gray because I'm just going to solve this equation. Now resist the urge to raise 4 to the power of 15. Notice that I want to solve this equation for x. So I'm going to look at this and say, oh, that's a 5th power. So I am going to raise both sides to the 1/5 power. And I know what you're thinking, Roger, why are you raising both sides to the 1/5 power? That's because when I raise a power to a power, I multiply the exponents, and I know that 5 times 1/5 is 1. Excuse me. And 4 to the 15th to the 1/5 is 4 to the power of 15 times 1/5. And then 5 times 1/5 is 1. So now I have a simple 3x plus 5. 15 times 1/5 is 3rd. So now I have 4 to the power of 3. And because I'm weird and do this all day, I just happen to know that 4 to the 3rd is 64. And now, oh, this is a 4. I don't know why I keep writing things wrong. I'm fired. This is supposed to be a 4. Let me try that again. So that's supposed to be a 4. That's a 4. That's a 4. That's a 4. So 64 minus 4 is 3x. 60 is therefore 3x. 60 divided by 3 is 20. And that is x. So what is the solution to this equation? It's x equals 20. 3 times 20 is 60. 60 plus 4 is 64. 64 to the 5th when run through log base 4 is 15. Let's try it with this equation over yonder. The base of this logarithm is 3. Y in this case is this number over here to the 10th. And the number the expression we put into the logarithm is this binomial. So now again, I'm going to look at this side, and since this has the variable, I'm going to raise this side to the 1/5 power, because then I will get this expression with an exponent of 1, which will allow me to use to solve for x. And now we have 3 to the 10 times 1/5 equals 10x minus 1 to the 5 times 1/5. 10 times 1/5 is 2. So we get 3 to the power of second is 10x. 3 to the power of 2, rather, is 10x minus 1. 9, 3 times 3 is 9, equals 10x minus 1. 9 plus 1 equals 10x by adding 1 to both sides. 10 equals 10x. So x equals 1. So just by way of review, whenever someone hands you a logarithmic equation, you can rewrite it as an exponential equation, or vice versa. These literally mean the same thing. So I hope that this was helpful, and happy logging.